Hi folks, and welcome to the Electronics Shop BCIT Technology Teacher Education. Today I'm going to be talking about power supplies and multimeters, critical pieces of equipment for the labs that we're going to be doing this year. Hi, and welcome to Electronics and the Technology Teacher Education program at BCIT. Today I'm going to be showing you how to use a couple of our bench instruments. We've got the multimeter right up here and the power supply right down here, and they're critical to pretty much everything we're going to do this year. Later on we'll get into using the oscilloscopes and the signal generator over here, but for most of your high school teaching electronic needs, it's a power supply and a multimeter that you're going to be using a lot. Now, in the high school, you might have different power supplies and different meters. This is the power supply that we're going to be making later this year, and you'll notice that it's only got one dial on it along with a couple of other outputs. But it does the same thing. Basically, it provides you a regulated, controlled DC voltage for your electronics project. It's just a little simpler and not as robust as the industrial ones we've got right in here. You might also have handheld multimeters, and they are great. In fact, this one has a few features that aren't on the bench-mounted meters, although the bench-mounted meters are the ones that you're going to be using for the majority of your work this year. Okay, so there's other things, and we've got different power supplies and different meters in the shop, and later in the video I'll take a look at how to operate some of them. But I want to go through some of the basic concepts of using a multimeter and the power supply on your bench. Now, before I do that, I am going to point out that the coil, the test leads, should be coiled neatly right here and hooked up out of the way so they're not getting in the way of the next person to come in and use the desk. Please leave them in that position when you're done at the end of the day. So we've got some test leads right here on our power supply, and they come down to alligator clips. Now, before you start using the meter, take a moment to check and make sure that the red lead is plugged into the red or positive output. This is called the banana plug, and it goes into the banana jack. Okay, and again, the black or your ground, negative, will go into the black jack. The green, or sometimes it's a yellow, but the third plug, if you have it right there, is your chassis ground. And that connects to the chassis ground right around the outside right here. This metal case is also connected to that. And that also goes to the ground plug on your electrical ground, so that this can be used to isolate circuits. We generally don't use that for the electronics projects that we're using, but if you want to mess with somebody, you can always leave that plugged in right there, and they'll probably spend 2 or 3 minutes trying to figure out why their project is not powering up, and they'll call me over to help solve it, and I'll probably forget to check that too. So before you get started, check and make sure that you've got red going to red and black going to black, and then nobody can pull a fast one on you. If you are messing around with somebody though, please don't swap the red and the black, because if somebody does come along and hook their project up with those hooked up backwards, that can damage their project. Red to red, black to black. Just double check before you even get started. Okay, great. So let's take a look at how we get some power here, and strangely enough, to get started, you press the power button. They'll all have power buttons, switches, they'll be in different places, and you'll see a couple of numbers flash up on here. You'll see the voltage and you'll see the current. And so right now, this power supply is putting out 13.0 volts, and there is no current going through there. Okay, that's great. We're ready to apply that to a load. Well, I've got some resistors over on this side, and the resistors will serve for our load today. Let's see what 13 volts looks like when we run it through a 100 ohm load. So this is a little 1/4 watt resistor right here, 100 ohms. And you can see that 13 volts, oh, it was looking so nice just a moment ago when it said I had 0.13 amps. Because of course 13 volts divided by 100 ohms of resistance should give me 130 milliamps of current flowing through there. So right now, I've got 0.14 amps or 140 milliamps of current. Okay, remember we like to use millis a lot in electronics because a lot of things we talk about are better expressed that way. Now, I think I can smell that getting hot right now, so I'm just going to take that off from right there. It cools down fast. Now, of course, if I go to a higher valued resistor, then that is a 10 megohm resistor or 10 million ohms of resistance, and I'm getting essentially no current flowing through there whatsoever. That's because this is so high of a resistance. There is a tiny little bit of current flowing through it, but it's in the millionths of an amp range. So that simply wouldn't show up on a 3-digit dial like that. We might be able to read that current flow using the multimeter. We'll talk about the multimeter a bit more in a moment. Finally, let's take this 2 ohm resistor and click it on right here, and we might see something interesting start to happen right here. Listen for a clicking sound. Oh, we didn't get a clicking sound on here, but you'll notice that we definitely got current flowing out here and our voltage changed. Now, this power supply is a 305, the 30 standing for 30, our maximum voltage, and 5 standing for our maximum current. Now this is starting to heat up quite a bit there. We're actually running quite a few watts of power through there. Just set that down over there. So we've got that electrical power flowing through there, and we've got the ability to set a maximum current. You could maybe see the smoke starting to come off that resistor. Well, if you apply too much voltage to your project, or you have a short circuit in your project, you can end up smoking your project as well. Generally, we don't want to do that. As nice as it smells. So what we have is we have a current limiting dial right here, and this allows us to limit the maximum amount of current flowing through our project. So if we want to dial in a maximum current limit, what you can do is you can take your test leads and create a short circuit. Now, you've got a fine and a coarse dial on here. Turn your coarse dial down fairly low so we don't get too much current flowing through there, and then just short those together. Now, generally, the power supplies don't like to be shorted out, but you can see here, because we've got our current dial right in here set down, we're able to now say, well, if there's no resistance in the circuit, if we've got this short circuit right here, because these two are hooked together, we can dial this in, and we can say, I don't want any more than 1 amp to flow through the system. And you'll notice that what it does is that this light comes on. You'll see a CC light flash up indicating that we're in the current control range, and as a result it's dropped our voltage down right here. So the voltage comes down so that we never get more than 1 amp of current, because that's what we set our current to be right here. So it doesn't matter if I play around with my voltage dial here, I'm not getting any change in voltage because that gets dialed back as low as it can go. I open that up, and now I'm no longer running current through the system. So now I can adjust my voltage on here, and I can bring it down to whatever I want it to be. So if you're working on a lot of our microcontroller projects, they might be at 3.3 volts, or they might be at 5 volts. So you could set the power supply up so that it provides 5 volts up to a maximum current of 1 amp. So if I now come along with this resistor, and it's 2 ohms, so keep in mind that with a 2 ohm resistor and 5 volts of current, 5 divided by 2, it's going to try to draw 2.5 amps of current, but you'll see right here that the voltage comes down so that we only get that 1 amp that we had it set to. And as a result, this time we're not going to see that resistor start to smoke because we're only putting 2 watts through a 10 watt resistor. Now, okay, keep in mind each resistor has maximum power handling abilities. Basically, how powerful a heater is it? Okay, so let's take a look at that in a few different situations and where this comes into play. Again, I was saying if you want to leave things messed up for the next person to come along and use it, turn your coarse and your fine current controls down to 0. because then, as soon as you come along and hook up any kind of load to it whatsoever, all of a sudden your voltage drops to 0 and your current control light comes on. So if you're not getting any voltage, check your current control light right here, because it's possible that somebody's turned the current dial all the way down to 0. Okay? Let's disconnect from right there. So if you need to set that up, when you're working on your projects, different projects will have different amounts of current need, and again, very few of them need more than 1 amp. So take your course dial and run it in and set it up so it gives you something like a maximum of 1 amp of current. That's probably way more current than you need for most of your projects. And then depending on the project, you can set your voltage to be either 5 volts, 9 volts, again, get close with the course dial and then bring it in right there, or 12 volts. I mean, it's so easy to do. Keep in mind that we're still limited, even though we've got 12 volts. There, you heard that click sound. When you hear the click sound go, that means that you're probably switching over to the current limiting circuitry in there, and we've limited ourselves to 1 amp. So less likely to smoke your project, but still likely to get enough voltage to power it up. Okay, so we've got a nifty power supply that has 2 controls, one for voltage, one for our maximum current. So long as you don't exceed the maximum current, you will get the voltage that you have dialed in here. But in the event you trigger a short circuit or there's something wrong with your circuit, the current limitation will kick in and hopefully prevent you from having your project go up in smoke. Okay, so that's the power supply. Let's just zoom up here a little bit and take a look at our multimeter. And again, the multimeters will have a power switch on them to get started. Okay, and you'll see a nice display right on here and neatly stored cables. Okay, in this case, we call them test leads. Okay, or probes if you prefer, and they're going to be plugged in right here. Now, again, you want to make sure that red goes to red, and it's pretty easy to figure out where black goes because there's only one black. Now, for the first measurements that I'm going to do, I'm going to plug the red into the red, right up top where it says V and, well, omega for ohms, okay? So right here you've got voltage and ohms, and we plug that right in there because that's going to let us measure volts and ohms. Later on, I might take this out of here and use this for measuring current. You can see that down below, we've got milliamps up to 2 amps, and we've got a 20 amp maximum right here. When you're measuring current, you're actually flowing the current right through the meter, so it has to run through a different circuit than when you're measuring voltage, where you're not actually flowing the current through the meter, you're just sensing the actual voltage. So we've got our power supply set up to 12.3 volts. Let's take a look at how we would read 12 volts on there. To do that, I'm going to connect the red right here and the black right here. And right now, it's giving me a reading that doesn't make a lot of sense. It's telling me 1.240. Well, let's make sure I've got the voltage button pushed in right here. Okay, and then the other thing I need to check is, since the power is coming off the power supply, so if it comes off a power supply or a battery, we want to make sure that we're measuring DC current. Later in the year, when we build our power supply, we'll talk about AC current, and to measure, and AC voltage, and to measure AC, which is a little bit more tricky than DC, what you're going to do is you're going to push the button in. So if you can see that little symbol right above my finger right there shows a button being pushed in, push it in and you get AC, leave it out and you get DC. Keep pushing it in and out, and Bon Scott shows up, starts singing Thunderstruck for you. Leave this button out because we're going to be working with DC today. This button here is for something called true RMS voltage, which only applies when you're in AC mode. We'll talk about it later when we talk about alternating current. Over here, you've got a list of the 3 things that the multimeter does really well: voltage, current, and resistance. And you can push in one of those. And you'll notice coming right up here, we've got a black line that comes up here, and comes along the top, and these numbers right along the top. Let me zoom in on that just a little bit. I've got to learn how to use this thing better. There's my telephoto button. Okay, as I was saying, these buttons right here each tie in to a black line, or in this case for current, a white line that comes along the top, and there's other numbers right along here. These are the maximum values that you're going to be able to read for voltage. Right now, you can see the button that we have pressed in is right over here, and that's pressed in too far. Okay, well, we don't have an option right here. This will go up to reading 1200 volts DC, and it will read 1200 volts DC when I push this button in, because that button is underneath the 1200 volt DC reading. And now you can see that I'm reading 12.4, 12.5. Down below on my power supply, it says I'm putting out 12.3 volts. And I'm only getting 1 digit of accuracy. That's because in order to measure a super high voltage like this, I can't measure it very precisely. I'm looking for a big number, but I'm supplying it with a small number, so it rounds off some of the decimal points. For 90% of our measurements, knowing the voltage to the nearest tenth is more than enough, but let's see how precise we can get. If I come down one more notch, this will measure to a maximum of 200 volts. And you can see I gained an extra decimal place of precision right here. But I can do better than that, because I'm only giving it 12 volts. I can come down here to measure to a maximum of 20 volts. And now you can see I'm getting 12.38889. Sometimes you will see a little bit of fluctuation in there as you go to measure it. Now if I go too far this way, okay, well now I can only measure to a maximum of 2 volts, but I'm putting 12 volts into it. So the multimeter is complaining. It's flashing this signal at me and telling me that the voltage I'm giving it is too high for this reading. So if you see a flashing signal like that, just push the next button higher and keep on going up. So for voltages, I can measure down below 200 millivolts or 0.2 of a volts. That's super fine. We won't use that all that much. Even the 2 volt range is pretty fine, but we'll use this 20 volt range with a lot of our DC projects, and we'll use the 200 volt range with a lot of our AC projects where we're using 120 VAC line voltage. I don't generally recommend projects involving 1000 volts AC or 1200 volts DC for your high school class. Your mileage may vary. So that's voltage with that button pushed in right there, and you can just hook that up and connect it across test probes. Here's an example of how I might measure that in a project or on my breadboard. I have my power supply set to 12 volts. It's delivering 50 milliamps of current. 0.05 amps is 50 milliamps. That current is coming in my positive line right here, connecting to the breadboard through a little red wire. Always keep your positive nice and red. And it's coming through a couple of resistors. Each of the resistors is brown, red, brown. So what have we got? We've got 1 for brown, 2 for red, with 1 0. So each one is 120 ohms, giving me a combined 240 ohms of resistance right there. Okay, so how would I measure my voltage across this circuit? Well, if I take my test leads right here and I place them right across the entire circuit, making sure that I connect firmly to the leads where it's plugged in, you can see on the multimeter that I'm getting my full 12.3 volts coming through the circuit. If I change the location of the probe and I come to somewhere else on the board, you'll notice that I'm going to get a different voltage. In this case, this is showing me that across this resistor, I have a 6.2 volt drop, half of my 12.3. You'll notice the numbers change a little bit. If I'm kind of loose on there, I've relaxed my hands a little bit, I don't have a good connection. Make sure you push those down nice and firmly onto your board. If I measure in this direction, I'll also get, let me get a good connection on there, a 6-volt drop, 6.2 volts. The drop across here should be the same as the drop across there, and these two voltage drops should add up to give me this voltage. In the event I hook them up backwards by some mistake, and again, it's not such a big deal because I'm just measuring things with these probes, you'll see that I get a negative sign showing up on the multimeter right here, negative 12 volts, and all that's telling me is that the voltage that I'm measuring is backwards relative to what the multimeter is expecting. So that's how you can measure these on your circuit board. And again, note that because we've got just a little current flowing through there, only 50 milliamps, we haven't had the current control limiting kick right in. In fact, we've got a little green light right here saying that we're under a constant voltage regime rather than a constant current regime. Okay, great. We've got voltage measurements going on. Let's take a look at how we might measure current. And to do that, we're going to press the, I'm just going to disconnect my power supply for a moment so I don't overheat those poor little resistors. Sometimes resistors will heat up a little bit. And let's take a look at how we're going to measure we'll get to current in a moment. Let's do resistance right now because I don't have to change this plug. We've got V and ohm right over there. So again, for measuring resistance, take a look. There's your ohm symbol. We want to measure ohms. Plug your red right in there. Black always, 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 always goes into the black hole. There's only one black hole. Make sure it goes in there. Okay, now just as with the voltage measurements, this black line comes up right here, and we've got our maximum readings along this line. We can read a maximum of 200, 2,000, 20,000, 200K, 2 meg ohms, and in this one we can go all the way up to 20 meg ohms of resistance. 20 million ohms is a lot of resistance. So let's take our 100 ohm resistor right here and find these test leads. And I'm just going to hold my 100 ohm resistor right across the test leads like that, trying to figure out where you can see that nice and clearly. I've got one test lead there, one test lead there, and I'm pushing on it nice and firm. And you'll see, disappointingly, that I read absolutely nothing up top. That's because this is expecting to read a 20 million range, and I'm only giving it 100. I might see more if I come down to the 2 meg range. And now you can see it's telling me 0.1 of something, okay? It's actually telling me 0.1 K, okay? This is going to measure all the way right through here. It's measuring in thousands of ohms, so 0.1 of 1,000 ohms is 100 ohms. If I come down to the 200K, okay, now it's telling me 0.07. Keep coming down closer, and at the 20K ohm, I start to see some pretty good numbers on there. Again, this is measuring in K ohms, so 0.099 K ohms, or in just changed over depending on how I hold it with my thumb. 0.1 K ohm is 100 ohms, which is exactly what we expect. As I come down to a lower number right here, get right in here, we're now measuring 2K, and here you can see that 0.098, okay, this is telling me that I have a 98.7 ohm resistor in my hand. Now I know that color bands on it say that it should be a 100 ohm resistor, but keep in mind that resistors do have an error tolerance. This has a gold band on it indicating plus or minus 5%, so I'm well within that. I'm only off by, what have I got? 1.5%. I'm doing pretty good for a 100 ohm resistor right here. Just as with the other readings, we can come down closer. You'll notice that this last one, when I switch in here, it finally switches into reading ohms because it doesn't say K on the label right up here. And so now I'm reading 98.55 ohms. So that works great for a 100 ohm resistor. We can measure it on the lowest reading right there. And if I want to measure my 2 ohm resistor, that's also going to work great on there. Look at that, 1.98. That's a pretty accurate resistor. But if I've got a 10 meg ohm resistor on here, I'm going to start getting that flashing sign, okay? And my 10 meg ohm resistor is just not going to cut it on here because I'm reading a maximum of 200 ohms. When you see that flashing, you need to start pushing the button in this direction. Okay, you don't have to push them one over each other. I'm doing that for dramatic effect. And even at 2 mega ohms, a 10 mega ohm resistor is still higher than that. I've got to go all the way up to 20 mega ohms. And now you'll see that it's actually reading 4.6, which is nothing like 10. And there's a reason for that. Because I'm holding it with my thumbs right here, my body is now part of the circuit. And when you deal with very high resistances, well, your body has resistance too. For instance, if I put my thumbs on here, you can see that my body has a resistance of about 3 ohms. I am basically, 3 in this case, mega ohms, because we're measuring in mega ohms out at this range. So my body becomes part of the circuit. I'm a parallel resistor to this little resistor right down here. So if I want to measure that properly, I need to not touch it with my body and instead just push it down right onto something that's insulating. And now you can see for high value resistors, don't touch them with your body, okay? And I get a fairly accurate reading of 10 mega ohms on here. Now, it gets a little bit confusing on these meters because it doesn't tell you whether you're in mega ohms or K ohms. So you kind of have to think about what are you expecting, okay? And what button did you push in? If you're on this button out at the end, you're getting it in mega ohms. If you're on any of the middle buttons, okay, you've got 4 middle buttons, you're getting it in K ohms. And if you're on the end button right here, you're getting it in ohms. Simple, right? Would have been nice if they could have just put a little display in there, but these are a little older unit. If you use a handheld unit like this, it will probably automatically tell you what you're reading in there. And anyway, yeah, it's got a little symbol on here saying whether you're in mega ohms or K ohms or just plain old ohms. But you'll get used to these. They're really useful that way. Okay, for measuring resistance on a circuit board right here, well, same thing. I've got 2 resistors in here. I know each of them's about 120 ohms. If I want to measure one of them, I put my test probes in here. And here I am. I'm up on the 20 mega ohms. Well, if I know that's supposed to be 120, I'm just going to come right down here and say, I'm less than 200 ohms. Supposed to be 120, it's telling me it's 117.8. Again, that's well within the tolerance range, and I expect that. This one might be a little bit different. Oh, 117.9. Those two are really nicely matched. Very, very close. Be great for making a voltage divider because you could get 50% of your total voltage right here. Now, if I want to measure the resistance put together, I put my test probes at either end, and I get the flashing symbol. Keep in mind, when you see the flashing symbol, that means that you move 1 click this way, measure it again. And that, of course, is because our combined resistance of 240 ohms is greater than the 200 ohms that we were measuring. So we've got 236 ohms here, and because we're measuring in K ohms, it's showing up as 0.236 K. So knowing your metric prefixes, as we emphasize a lot in electronics, is pretty important. The third thing you can do with your multimeter is to measure current. And to do that, you have to press the A button for amps. And as I was saying, you have to unplug your red test lead. And then you need to choose whether you're going to be measuring 2 amps or less or 20 amps or less. Pay attention, different meters might have a 10 amp maximum right here, and some might have a different maximum right here. So you can see right there, we've got 2A max written on there, 20A max. They even put a little exclamation mark as a warning sign. We're going to measure up to 2 amps max. If you're not sure how much you're going to be measuring, okay, always start with the high one. And if you're not getting an accurate enough reading, then you can swap over to the low one. Okay, if you do go to measure with the high one, be aware that your 20 amp setting right there has to match your 20 amp setting right over here. So this button only works with this hole right here. Okay, so we're going to start by measuring how much current flows through our resistors on this board. Now, in order to measure that, you actually have to break the circuit, because right now the easiest path for the electricity is to come through here, and out this side. There's nothing in this circuit that would force it to come up and through your multimeter. And in order for your multimeter to measure the current flow, you need to take it away from wherever it's going and run that current and force it to go through the meter. Okay, so what I'm going to do to measure that is I'm just going to take this wire out and put it one hole over right in here. So now I've set up a little trap right here. The electricity is going to come in right here, okay, but it can't get to this lead right here unless I give it one more wire to connect those two. And the wire that I give it to connect those two is going to be my test leads, because I am going to force that current to come in through there. And in order to get over there, it's going to have to come into the red line, come all the way up through this red line into right here, get measured, get counted, how much is flowing through there, and then it's going to come right back down here and flow through the rest of the circuit. And really, in this case, my multimeter is going to look to the circuit just like another wire, but a wire that's secretly measuring how much is flowing through it in the background. Okay, let's hook up some power right here and see how that works for us. Okay, so right now I see no current flowing through right here, which is exactly what I want. I'm going to connect my multimeter right here and then connect my multimeter right there. And now you can see I've got current flowing through the circuit. And what it's showing me down here, I see 0.05, okay, so 50 milliamps flowing here. And right up here, I'm in the 20 amp range. And so this is showing me 0.046 amps. Now I can get more accurate readings by bringing this down here. And as I do, I shift into the milliamp range, because you can see these buttons start to get M's in front of them. So I can keep going down. And if I go below 20 milliamps, well, it starts giving me grief, because I'm actually delivering 50 milliamps or 0.05 amps. So I bring that up one more, and there I can see it very nicely. There's 52.72 milliamps flowing out of here, or coming through this wire, coming in right here, up and around this way. They go into the multimeter, back out this wire, and back down into the circuit through the two resistors and back to the power supply. So when you're measuring current with your multimeter, very, very critical that you break the circuit and force the electricity to go back into your meter. So those are your three primary functions. Voltage. For voltage, make sure you're plugged into volts up here. Resistance, also plugged into the top one. And current measuring, right into these ones down here. You've got range buttons to control your maximum range. And you've also got an AC/DC button over here to control whether you're measuring AC when it's pushed in or DC when it's pushed out. And unless you know specifically that you're measuring AC because we're doing an AC project, it's probably going to be a DC measurement, so make sure that button's out. And that's about it. I'm going to show you a couple of the other multimeters and power supplies that we have available in the shop. But your general function on your power supply is that you've got current limiting dials that limit your maximum current that you can get. And you've got voltage dials that control the voltage that it will supply. So right now, I will get 12.3 volts up to the maximum current that I've set right in here. Setting a maximum current is a way to keep your project safer than it would be if you didn't have a maximum current setting. Okay, there we go. There's the general functions of multimeters and power supplies. in just a moment, I'll show you a couple of the other ones that we have in the shop, just because. I almost forgot. When you're all done, make sure they're turned off and that your cables, your test leads, your probes are neatly disconnected from your circuit and hanging on the hooks for the next person to come along and use them. Tidy. Nice. Okay, down here we have an analog power supply, and it works very much the same way. When you turn it on, you'll be able to adjust your voltage. Okay, and you have to read that dial on there. And then you'll also be able to adjust your maximum current. So right now it's showing me no current flowing in here, but these current dials work the exact same way. If I wanted to set it to a maximum of 1 amp, I'd just connect these 2 leads together. You get on there. I'm trying to do this with one hand while I film. There we go. And now I can dial my current down to a 1 amp maximum right on there, so that no matter what kind of short circuit happens or how things go on your circuit, will never exceed 1 amp, and then you can dial in the voltage that you want. In this case, I've got it set to 9 volts. When you're limited to your current, you'll see that CC button turn on right there. Leads neat and tidy before I walk away. Here's another power supply, slightly different configuration. We don't have the fine adjust on here, but you've got a voltage dial and a maximum current dial, and again you can set that up. Remember that the green test lead right in here, we don't use it that much. That's your chassis ground. These are our newest power supplies, and the power button I've got figured out. In order to set your maximum current, you actually need to push a button in here, right here. So you can see that these little dials have a little label next to them that says push hold. So if we want to adjust our current control, I push that button in right there, and while it's pushed in, I can dial in the maximum current that I want. And so if I want 1 amp of current, I set it to 1, and I just let it set for a moment, and there we go. Now I've got 1 amp of current set. And to adjust my voltage again, I push it in, and I don't want 29. There we go. I push it again, and now I can adjust the single digits on there to get it down to 5 volts. And then I just let it set for a little bit. And there we go, 5 volts at a maximum of 1 amp. And here's my buttons on, or indicators on here. This is showing me that I'm in a constant voltage mode as opposed to a constant current mode. So we've got same sort of thing, just different interface for using it. You'll figure it out when it comes time to use it. Also over here we've got a different multimeter and power buttons right here, test leads right up here. You can see the voltage in ohms goes in right there. This one has a 10 amp maximum there, and this one has a milliamp setting right here for measuring your current. And again, there's only one black input. And here we go, we've got functions. This includes voltage DC. You can see the flat line to indicate DC if you want to measure DC volts. We've got AC volts, that's the wavy line. We've got DC current, AC current. We've got ohms, and this one has a few other things on here for measuring diodes and circuit continuity, and it'll even measure frequency. And here's all of our range buttons right down over here. Okay, there's also a hold button on here. If the hold button is pressed, then it holds whatever the last value is. So if you want to show me something that's going on your project, just get the reading and then press hold, and that reading won't change, but let go of it when you're otherwise trying to read something on there. Okay, 200 to same buttons right along here, and they work with those different settings. This one also has a neat little feature where you can test transistors on it. Not all that critical for anything that we've got going on. Okay, so it looks different, but it works the same. Here's another multimeter. Again, it looks different, but you've got a power button right there. You've got one black input. You've got one red input right here. These two are white because they're for current. Okay, so 10 amps and milliamps right here to 2 amp max. You've got an AC/DC button right there. Let's come in a little closer right here. You've got your voltage, current, and ohms, and then you've got your individual scale readings right on here. So almost the same, buttons in a different place. This one, if you're reading higher, rather than flashing zeros at you, it shows you a 1. Different meters will have different things. Usually there's some kind of indicator that says, I'm getting a reading that doesn't make sense. And then you have to just keep changing your scale until you get to a range where the reading does make sense. In this case, there's infinite resistance, so you're going to get that no matter what the scale is. And here's yet one more style of bench multimeter. Power button's not hard to find. Black button's the same, or sorry, black lead's the same. Red right here. This one's a little different. This one can do something called 4-wire sensing. That's for super accurate, precise measurements. We're not going to need to do them. So where it says 4-wire, don't even worry about that. Right down here, this one has a 2 amp maximum current reading right down here. Okay, this one also lets you switch your inputs from the front to the rear. Make sure you're using the front inputs if you're plugged into the front. It's got a few other buttons down here that you really don't have to worry about too much. The offset reading will remember what you're reading right now, and then it will just read the offset from that, basically like a 0 or a tare button on your scale. And here we've got the different things that we can read. Ohms, 2-wire button right there, and then you push what range you want to use. Works just the same as all the rest of them, even if it looks a little differently. For those of you unfamiliar with electronics, you'd think fluke would not be the name that you'd want associated with precision measurement, but yeah, fluke multimeters, you're very fluky if you get one, because they are excellent pieces of electronic equipment. I almost forgot to add one more final but important thing. When you're measuring current, most multimeters will have a fuse to protect the multimeter in the event that you try to run 10 amps through the 2 amp side or 40 amps through the 20 amp side. So let's just take a look right here. In the event that you're reading absolutely nothing when you're trying to read current, it could be due to a blown fuse. And it took me a while to find change, actually. These ones are designed so that you can open them with a quarter or a dime or something like that. I haven't used change in the last year. I guess you could open it with your credit card too. I've been using that a lot. Or just a big flat bladed screwdriver. So if you're trying to measure current and you're seeing no current go through there, just take a look and make sure that the fuse that's in there is solid all the way through. You can see that that one is continuous. There's no smoke inside the fuse. And that little piece of wire inside there, if you try to run more than 2 amps through this connection right here, this will heat up and rapidly go up in a puff of smoke. And that'll be it. You won't be able to use the meter anymore. Just a minute. 250 volts. Oh, okay. I was just checking my current on there, make sure that it's actually a 2 amp fuse. Anyway, so we've got that right in there, and just put that back in and check your fuse if it's not working. Almost all multimeters will have a fuse somewhere in the current measuring side. And there we go. That's it. Multimeters and power supplies. We'll talk about the more complex stuff later on, but that should get you up and running. Have fun. Try not to make anything go up in smoke, unless you really want to.